Namaste everyone. What is the weight of a body of mass 3 kg at a distance of 6,600 kilometers from the center of the Earth? Take the value of acceleration due to gravity on the surface of the Earth as 9.8 meter per second square and radius of the Earth as 6,460 kilometers. Now, we have the variation of acceleration due to gravity with the height, because this 6,600 kilometer, it is from the center of the Earth. And actually, the center of the Earth to the surface distance is 6,460 kilometers. That has to be taken very carefully. So this comes out then. 6,600 kilometers will be out of the Earth's surface. So let us see how much that height will be from the surface of the Earth. So radius of the Earth is 6,460. So 6,460 kilometers. And the point is outside because it is more than the radius. It is 6,600 kilometers. So how much is the height? That is what is needed now. So height is 6,600 minus 6,460. 6,460. So that comes to 4 here, and this will be 140 kilometers. Because everything is in kilometer, that has to be taken care. But here, if you substitute the values in kilometers, no problem, because the formula itself will have two heights in the numerator and denominator. So this is 140 kilometers. So you have to substitute the height as 140 kilometers. And 140 kilometers height is much less than the radius of the Earth. So you can use the formula G dash, or G at a height h is equal to G into 1 minus 2h by r. And if the height from the surface of the Earth, this h, is very large or very comparative to the radius of the Earth, then you have to use the formula G dash is equal to G into r by r plus h whole square. So if h is not very small, if h is comparable with the radius of the Earth. But here h is very small. So this formula need not be used. This is okay. What is G dash? G dash is equal to G, acceleration due to gravity on the surface of the Earth is G, that is 9.8, into 1 minus 2 times 140 kilometers. I don't convert kilometers into meters. Of course, if you want, you can convert it. 10 to the power 3 meters divided by radius of the Earth. Radius of the Earth is 6,460 kilometers. And that gets cancelled. Kilometer gets cancelled. Now we can directly calculate this using the calculator. If I open the calculator, cancel. So 2 into 140, that is the 280 actually. 2 into 140 will be 280. Sorry. 2 into 140, that is 280. Yeah. And divided by 6,640, divided by 6,460. 6,460. That comes to this 0.0433. And this should be subtracted from 1. I will do minus 1. Okay, no problem. I'll get negative answer. Actually, it should be 1 minus this. This thing should be 1 minus so much. But I did minus 1 into 9.8. So at a stroke, I can complete all the calculations. Into 9.8. I got minus because I made this minus this one. Actually, it should be 1 minus. Okay. The answer is 9.375. So 9.375. G dash is 9.375 meter per second square. So what is the weight of that object at that height? Weight and the mass of the object is 3 kg. Weight is mg dash. And that is not the weight on the surface. M is 3 into 9.375. So many newtons, because you have maintained all the SI systems. So I have to multiply this with the 3. That's all. 3 into 3 gives 28.125 Newton. 28.125. So you'll have to take care only in the writing height and selecting the formula. Whether to select this formula when height is very large, and that means it is very close to the radius of the Earth, and when height is very small. But height has to be taken not from the center, from the surface of the Earth. That's the only care you have to take in every problem in this area. Thank you.